like to welcome our next speaker, Pius Dunn, who is a site reliability engineer at Loanbee. Welcome, Pius.
Yeah, so as they said, I'm Pius Dunn. I work at Loanbee. I'm a software engineer, day-to-day technical tasks. Yeah, so I'm sorry Miles could not make it. I know you wanted to hear from Miles because he mainly deals with the machine learning models. For me, I mainly deal with the infrastructure bit, like how do these machine learning jobs run in the cloud or whatever place we run them. So I hope you find it interesting. Just know the crowd, like how many of us actually do machine learning, like, how do I say, actually data scientists, like from Monday to Friday, yeah, or Saturday. Oh. Yeah, awesome. Yeah, how many developers, like you just write code? Oh, awesome. Then what the rest do? Okay. Okay, I know. Yeah. So
the rest have money.
The rest have money. Oh,
yeah.
we know one who has money, one who keeps money. So so how many are students? How many want to get into AI? Oh, that's awesome. Oh, interesting. Yeah. So I think that's at least I know what around 60% of us do. So I think we can start it off. Oh, so how many love Game of Thrones? Yeah, so I think Miles is not coming, but Winter is coming though next year. Yeah, so before we start, I think what I'll talk about is our journey towards machine learning, how we moved from a startup that was just a loan app, maybe serving some customers, just giving out loans, how we moved from a fintech that just disburses money to our fully fledged loan application that we are even talking of giving credit scoring engines. Yeah, like you're doing engines, you're engineers. So before we start, I think this is the lesson we learned. I found this quote somewhere. So every engineer, or every developer, or every student wants a PaaS. A PaaS is basically a platform as a service. Like you build you have a platform that services you. Like when I talk about credit scoring is generally platform as a service. So we build a platform which is credit scoring, and then we offer it to other people. So lenders who come into the market don't need to build the whole thing by themselves. They just need to know how to get and receive money, and then we do the rest. Yeah. So every engineer wants that, but the only requirement is it has to be built by them. Yeah, so we experienced this thing, and trust me, it's not a good thing to have. So just an advice, if you are trying to do something and you find there's a platform out there doing it, a service being provided, kindly use it. Don't try to build your own. Okay, you can do if you want to flex your muscles, but we learned it the hard way. So my slides are a little bit boring. Okay, generally I'm usually a funny person, but I couldn't. My slides are a little bit boring. Hope you'll cope with it. So I was told to discuss how our credit scoring is done. So first of all, we accumulate users' data over the past few months. We look at 6 months or 3 months, and that data is big. We're talking here 5 terabytes. 2 if you're lucky, 5 mostly. Yeah. So we've been in operation for 1 year. So if you want to dive into the field, don't be scared. It takes time to accumulate such data. Yeah. So based on the data we get from the user, we run check frauds. So first of all, the first fraud we do is at the doorstep. Like when you get the data, is the data valid? Yeah. We just check if maybe. Does this data belong to this user? You have someone talked about identity theft. Yeah, so you can just look at data and just know, like, okay, this is false. Like you try, like if you're changing your SIM card every day, there's no way you can have messages past 3 months. So we just look at your data and know like, okay, you changed your SIM card yesterday, so we stop the process from there. So if you proceed, wow, did I rate molest? Hope we don't have. Yeah. So yeah, basically, yeah, you have to crunch your data, molest it until it gives you answers of how your customers look like. Yeah. So yeah, that's basically how we do the credit scoring. I'll come to details later. So our tech stack. Most of the things run on Kubernetes, on GCP. Okay, I promised no buzzwords. So basically, we have a cluster of all our services that run our apps, and then we package them in form of Docker. And then other things that cannot be run on Kubernetes, like our databases, we use Google Cloud platform, and even some we do for data. We actually really use BigQuery. I'll come to why we chose it. And then most of our stuff is done in Python. We have some Elixir, but mainly Python. And then Java for the client apps. Yeah, so the customer journey, so the user signs up with the platform. Now you have the Android app. User comes, you log in. After logging in, we ask you for permissions to access your call logs, your location, but we discontinued location. I'll come to why we did that. We ask for your location. We don't ask for what you ate for dinner, so don't be. You're not that creepy. So you just take your messages, your call logs. Yeah, I think that's basically it. And then first of all, we run KYC checks. This basically know your customer. We currently use TransUnion. TransUnion is a credit bureau, but they also offer KYC checks. So basically what this means is you are just checking if this ID number belongs to the person of this name with that age. Yeah. So KYC is basically know your customer. Yeah. It's know your customer. Yeah. So what does that? Those are details about your customer, like when is your birthday? What's your name? What's your ID number? You just need, those are details that will help you as a business know your customer better. Yeah. So what we just do, we just try to validate if this number, ID number, date of birth, and name belongs to the person who is trying to access our system. Yeah. So that's basically KYC. I don't know why it's called that. We can call it user profile or something, anything else. And then after that, that's when the work begins. From here, we've already stopped some attempts of maybe fraudsters, like people who do not have matching ID numbers. So those are cut off before they get to our platform. So after that, that's when the job begins. We start uploading user data. This is done in batches. We have the Android client. For a startup operating in Kenya that you rely intensively on data, it's a little bit tricky because you're talking about megabytes of data. Your app is maybe 7 MB, but you have to upload maybe 50 megabytes of data, and at very slow connectivity, and you have to give them real-time feedback. Bearing in mind this data, you have to go extract it and then throw it at your machine learning model, apply business rules before you give out feedback. And you need to do this in near real time. Our data, it's a little bit tricky. So what we do, we run it. We don't try to be optimal at first. We try to give a user. We try to score a user first, like run a risk profile before we get all the data. So as time goes by, we are beginning to get a clear view of the user. But we have a minimal. Like we decided, like this is the minimal data we need, maybe to like just give you a rough score. And then for the first loan, it's usually not about how rich you are or how much you can repay, but we're just testing your character. We'll give you a small loan. We'll give you 1,000 bob. We're thinking of doing 500. Just test, can you repay? And then after time, we believe by the time you repay, we'll have accumulated enough data now to score you. Okay, don't tell anyone we don't score. We score them after a month, but yeah, I think that's when machine learning stops and engineering comes in. Like you need to know, you need to be aware Or you can't say you'll just collect a gigabyte of data when someone has this 20 MB bundle. You get it? Like Loanbee alone will be using you'll be giving someone a loan so that he can buy credit to upload their data, which is not which is not logical at all. So we upload it in batches, like small batches at a time, and then try to build like maybe a data profile first before we even build a risk profile. So that's when we run frauds detections against the data. Just look at the size of data, look at the call patterns. Someone can just buy a SIM card today and then start calling a lot, and then when you look at the call logs, he has so many call logs, but that's fraud in waiting. So we look at even the call patterns, the message pattern. Are you sending so much? So that's basically to be able to look at how fraudulent, like to give you maybe a fraud profile, like from the most risky to the least risky. So after that, now that data is fine. We know, this is someone you can work with. And then we pass it through our model, our machine learning model, and then it gives a user credit profile. But it doesn't end there. That's just the start. Like machine learning is it's just a small bit of a whole big ecosystem of what we have, because we also have business rules. We have a financial guy. Yeah, we have those people, the ones that suck. Yeah, we have a financial guy. He does the risk evaluation. And he does the risk analysis, develops models for loaning, because we actually do something like a bank does, but it's just we use technology. So machine learning is just one part of a big ecosystem. So that same profile has to pass through through some other checks and balances so that we can give you a full risk profile. Yeah. So that's it. We have a user device. The user device uploads data to transactional databases. So when I say transactional databases, these are the normal databases used: MongoDB, Elasticsearch, Postgres. For us, we use Postgres. We just store our data there, just accumulate data. But this data, you can't just do machine learning on the data. You understand that. For guys who do machine learning, you understand that you have to do the extract, transform, load pipeline. So while data is sitting at our transactional databases, we have jobs that are running sequentially. The extract, transform, and load jobs that extract data from here and push them to BigQuery. So the logo here is for Cloud BigQuery. Yeah, it's for BigQuery. So BigQuery, it enables us run it's an offering by Google that helps you. Basically, it helps you transform your data, so you can run very complex queries in seconds, things that will actually slow your databases. So that's why we separate them. This is because for us, we are a startup that will be doing this for 1 year. But if you want to do it, one thing I should tell you is that don't rush for all this fancy stuff. Okay, they're not even yet fancy, but with just SQL, you can do so much in terms of extract, transform, and load. So what you are doing earlier before BigQuery came in, we just said a Postgres database that was a master, and then we had just replicated the database into a read replica. So we'll do all those extensive queries on the read replica. But then there comes a problem. The way you store data for transactions is not the same way you store data for analysis or business intelligence. You need to store data in form of dimensions. That's where things like Cassandra come in, things like BigQuery come in. They enable you, you can be able to store your data not in form of, for Postgres you have, for relational databases. Hope I'm not being so technical. Yeah, so for relational databases, you store data in form of relations. So to be able to maybe a user account, a user profile, these are all different relations. And then for you to get maybe a person who registered on 28th March, whose name is this and whose ID is that, and don't know he ate what for dinner. Like, you'll do very extensive queries for that. That really slows you down. So what we discovered, it's actually a new thing. We are trying to do work on it. Instead of all this fancy stuff, because trust me, BigQuery really costs you. You'll actually see it. It's really tough every end of month telling the finance guys that, we just spent like $100 on BigQuery alone, and then when all your servers complete cost something like $200, and then only one thing costs $100. So it's really hard doing that. So if you are trying to go mean, if you're trying to learn, there's something called dimensional modeling. So you just don't store data relationally. Okay, you can store it in a relational databases, but in form of dimensions and facts. So the dimensions can be maybe like the query I told you about, where you want to find, you want to aggregate all users who registered on 20th March. So you have to, for that you most probably do some very crazy join and don't know where. But when you're doing dimensions, so you store data in form of, the dimensions are basically, dimensions can be time, dimensions can be maybe age, gender. So these are dimensions. And then the facts, and then you have dimensions and you have facts. So the dimensions are basically context. And then the facts, it's the actual data that you're storing. So for us, we have the things like age, gender, location. Those are all dimensions. And then our facts are maybe, so the actual information, maybe ID number, your name, those things that, actual factual. But the things that, the things that can apply to many users across the board, you just have them across as dimensions. So that really helps you. So from several joins, you can just do one select query and get all the data you need. You don't need to do those crazy aggregations. Yeah, so you could probably look at that. So here, I was at BigQuery. After we explore the data, we run the queries, we dump them to a CSV. So we get the features that we want, and then we dump them to a CSV. And then the machine learning guy comes in, he writes the Jupyter notebooks for them, and then we upload them to SageMaker. So SageMaker enables us to run it just helps us train our models. It's an offering by Amazon. So I think the only problem, no, it's actually right. Yeah, so I wanted to say that our first approach was, we were doing it directly. So the reason why I said don't build a PAS by yourself. So we had this, we are a small team, we're only 9 in our team. So one person can actually work on one thing at a go. Like for the machine learning guy, he just does machine learning alone. Then so we were one team, and then because we had seen these technologies in Apache Spark, and then this Kafka. Then you're so excited by the day of streams, just have near real time, whereby you have Kafka doing the streaming, and then your ETL jobs are running on maybe a Spark cluster. And then it was so good for us. We spent close to 5 months doing that thing, and then at the end of it all, we were nowhere. We just had so many bugs, like you're waking up in the middle of the night, I don't know which job failed where, and then those crazy server bills start to accumulate. Okay, it works for people, but for a startup, I'll advise, don't try build your own PAS. If we have offerings like BigQuery, things that, and then Amazon have, I think, Redshift. Yeah, so try as much as possible, use what's in the market. It's fancy to do all those Kafka things when you read them, but it's not really interesting when you start doing that stuff. That's how it's strenuous. Yeah, and especially if you have a small team. Yeah. But in future, we hope we'll do something like that, hopefully. Yeah, so after we generate the model, now from then on it's back to engineering. Data science ends from exploring data and using Amazon SageMaker after training the model. Then model is dumped to S3 storage. those are just buzzwords. It's SageMaker does everything for you, so you just need to know what model do you want. So after we generate the model is packaged into a Docker container, and then with the Python API, it's a really simple API for Python. How many of you know about APIs? So API is just an interface that other systems can communicate with your program. So you need to expose your model using something. So we run it on Kubernetes. And our servers, as I said, our servers don't rely on Kubernetes alone. We have most of the stuff are Kubernetes because it's easier to do containers. I think if you guys don't use containers, you should really look at them. They automate so much, especially with a small team. So we just dump them to Docker containers, they run, they manage. And then you have the Loanbee services. Now, all the other services, they kind of communicate together. So basically, the API exposes an endpoint that you put your data. So after the training, so if a new user comes, all we need to do is just extract the data that we need and then send it to the API, and then we get a prediction. It's much easier. But what you're working on, we're working on now building a fully fledged data warehouse where the whole process is automated. For now, if you sign up, we take your data and then put it, throw it at the API that's running the model, and then gives us feedback. But you want it to be automated. As soon as the data lands into the data warehouse, the process is done for it, and then a credit score is evaluated. So when the user comes looking for a loan, you don't have to do the whole process again. So it's things we are trying to do, but for now, because of the team also, it's a little bit hard. No, we are taking things slow, together with the learning curve and technical depth. And then after that, it's just simple as a user receiving a notification. Okay, you have an offer from Loanbee. You have $1,000, 1,000 bob. You can borrow up to 1,000 bob. Or, I'm sorry, we can't give you a loan because you're a fraudster. Okay, we don't say that, but that's what we mean when you say we can't give you a loan. So that's basically it. That's our architecture in a nutshell. Hope I haven't gotten into details because I was told not to get into details. Sorry. Can I ask now or okay, you can ask now.
Just go back, that one. Correct me if I'm wrong. From your architecture, what you're saying is the transactional databases actually does not, that leg doesn't give responses back to the user, but this other one, Loanbee services, does. So the other one is to feed to your artificial intelligence machine learning. Is that correct? That's the first question.
Sorry, I didn't get it. Sorry.
This leg here, This I'm assuming is a mobile app.
That's a mobile app.
So there are some things I'm doing on your app, and I get response from Loanbee. So whatever I get response from is here.
That's where it gets response.
But this one is for your data.
That's for the data.
Okay. Now my question is, at this point, what's the highest TPS you've ever achieved, like transaction per second, and how is the impact on your Loanbee services? How have you modeled your architecture?
Oh wow! I really hope it won't be it will be more of the machine learning and less of the engineering. So I think the highest it's mainly on Friday. Transactions get to, I don't know, let's say 1,000 maybe. Because you have everyone in a club hitting that get loan request. Get it. But how we model our services, we've actually modeled, our approach was fail fast, and then fail fast, get up early, basically. So what happens is that, the processes are really slow. Like for you to get a loan, for you to get a loan profile, and okay, before you get to that, you have to, like when I talk about 1,000 or more, because you're talking about a typical user who wants a loan. Maybe you are stranded somewhere and you're getting a loan, so you're tapping that button every time. So you get that button is hitting our gateway, like every time you tap it has to hit it. So first of all, we upload your data. So for people that upload their data, we just break those connections. After you uploaded your data and you request for another one, then you continue refreshing hitting that refresh button, we normally break those requests. We just have a time, like our gateway is configured that it has a time frame. If a user has uploaded data in the last 2 minutes, we don't respond to such requests. So that's one, we actually reduce hitting our caches. And then from going forward, we first start by hitting the caches to see if maybe a response has come, or maybe we sent a response, it failed somewhere. Yeah, so that's it. So how we structured our architecture, we have all the services running on Kubernetes pods. Okay, earlier we were using actual virtual machines, and then we had Zookeeper, like we are using our own, like kind of our own cluster. So we have Zookeeper to actually maintain the clusters, but it was really stressful for us. That's why we moved our workload to Kubernetes. So for Kubernetes, you just need to write your applications and then give them, like, you package them in form of nodes. Nodes are basically, hope that wasn't bomb plus yourself. Yeah, so when you package your application, you tell Kubernetes, okay, if my traffic spikes, you spin up maybe 4 more, and then, if traffic goes low, you spin up 1 more instance of the same. So between when the services are communicating, we do have timeouts, like timeouts and circuit breaking. So we say requests, like for an average request within the servers, you're not supposed to take 0.01 seconds. So by that, things are able to break faster within our platform, and they're able to respond to challenges faster. And then I think one thing we noticed, even before building that whole infrastructure, because it's been a while, most of the things maybe we have a problem yesterday, so we wake up and build something. So it's kind of an evolution. You can't just wake up and think of the perfect infrastructure. So I think one thing, if you want to build something like that, just invest on, leave everything alone, build your app, whatever it is, and then invest on monitoring. Just know what's happening. Just know where the traffic is going. That will save you a lot. So from there on, some things are just common sense. Like if you find this service being overloaded, you can choose to maybe add more, like scale it vertically or horizontally, depending on what you're using. So for us, it's about making impact on the world. Like as much as giving these people loans, helping them. These loans, you're not about giving you loans, but actually building a credit profile for you, so that when you are 24 out of college and you want to start a startup, you don't have previous banking experience, but because we can give you a credit profile, we can tell a bank to give you 100,000, because we know you're actually a good repair, even if you don't have money now. You get it? That's what we were there for. It was not about giving people loans. Okay, we had to give people loans to be able to do that. Yeah, so now we've given out loans. We have data that's spanning 5 terabytes. We can actually generate so much insights with it. Like we are doing so much research. So I'll come to it. Like one of us went to Dipindaba, who was presenting something of fraud analytics. That's what you're trying to build. You're trying to build systems that can leverage on this new thing, like M-Pesa, your M-Pesa transaction history. Systems that can leverage on M-Pesa transaction histories to give you loans, or even help you win tenders. Yeah, I know all of you want tenders. Yeah, so things like that, because they read a credit profile for you. You are 22. The only your interaction with the bank was receiving help. Hey, okay, for me it was that. Hey, man, I had an account. It was basically help, like 1 time in a month. It was 2 times a year. It usually had some amount, and then immediately money enters, it comes out. So that was my credit profile. No one can give me a loan at that time. So, but M-Pesa, like most of us here know their mama mboga or know their kinyozi. Sometimes you can just go there and tell him, I need you to shave my hair, but I don't have money. You'll get money. Your profile, like that's your risk profile. You're trying to convert that. You're trying to make that digital now, in ways in which people can see, not only Mama Mboga, but we are now talking about you interacting with banks. Yeah, you get it. So that's what we are in there for. So first of all, we just went on a data collection drive for around 1.5 years now, using the loan app. Now we have a lot of data. First, our first step was just get our data into SQL. Trust me, it's easy. It's very easy. It's very easy as say it, but just getting your data into a form that can be queried. Trust me, it's a really interesting engineering journey. There are ups and downs, there are tears and everything, but it's really a nice thing. Now we have our data in SQL. So, and then after that, now we kind of use Spark to just move the data from SQL into BigQuery. That's what we have now, and that's what our credit scoring engine is built on. And then from BigQuery, that's where you have machine learning. Yeah, so the reason why I'm highlighting this, because for the training of the models, you can build even the best models, but without enough data, your models are just as good as the assignments you actually given in campus. That, yeah, you get it. So, but with much data comes much insight, just as much, I think, much responsibility. Yeah, and I think I don't know if it's the next slide. So, before I go into the pitfalls, one thing that really concerned us was how we store the data, like how do we secure. These are people's most intimate things you can have in your organization. Having people's messages. I know it sounds cool when you tell people, okay, we get people's messages, but really as a person, it's so much than just asking a user that allow us to take your messages or anything. It's much more intimate than that. This is someone who trusts you fully. Trust probably more than they trust their girlfriends. Yeah, Yeah, so, and then one thing I should tell you is that scale when only you need to. That's why I said monitoring, invest in monitoring first. So that will save you on cost, and it's also save you on the size of your team. We manage all those requests, all those requests per second. A team of 9 guys. The 9 guys, not all of them work on tech. I think 12 or 9. Only one person does the backend. One person does the infrastructure. One person does machine learning. We have 2 people on the backend and then 1 person in the infrastructure, 1 person on the machine learning. So we've been able to do that for 1 year without, okay, I think we came in later. It was basically 1 person, and then we had to add a few more people, and that has been through a year. So be lean, like just minimalist. Okay, minimalist is better. Be as minimal as you can, but minimal in this term, not minimal to you as a business, but minimal to the end user. No, minimal to serve you as a, don't, when you are creating how to be minimal, don't look at you as a business in saving costs, but being able to deliver the best results to the end user at a minimal cost. That should be the first priority, because if you say you want to be minimal and lean on your costs and everything, you won't like, you'll just pick most of this open source stuff which are really insecure, and there you have people's actual messages. And then we try to anonymize the messages as soon as they hit our servers. No, they are anonymized at the phone before they leave the phone. We anonymize the data and then send it. Only the phone knows, like, this data belongs to where. Yeah, and then use what you have or no. Beware of technical debts. Yeah, it's really good, especially as a startup in machine learning. Machine learning is a thing that most people are trying to understand. We find, okay, in Africa, big data is just hitting us recently. We have very few startups which can brag of having big data, actually having big data. We were trying to propose better methods in which financial institutions can use to detect fraud, because we are experiencing a new form of fraud in the fintech sector. I won't say there's nothing new under the sun, so it's not a new form of fraud, just something we had not been aware of, whereby you have people who take loans. For now, when you talk about identity fraud, if you're still dealing with identity fraud in the financial sector, I think you're a little bit left behind, because people evolved. Like, if you still haven't covered that, it's you still have a long way to go. That's why you have the credit scoring engines. So now we are having people who just not who have a good profile. You have good debt. You've been using your phone, but maybe it was in your character not to pay loans. Now you have to curb those people who don't repay your loans. But not all people who don't repay are fraudsters. Some are genuinely, maybe they're genuinely broke, and when they get money, they maybe become the best customers you have. Yeah, so it's a little bit tricky scenario whereby you're trying to retain as many customers as you can, and while the main emphasis being you just eliminate fraudsters from your system. Not people who are out there to actually do fraud, but people who even themselves don't know they're fraudsters, but they're actually not repaying loans. People who are just using, those guys who tell you, help me with 1,000 bob, I'll give you by the end of the month. And then at the end of the month, he'll actually buy you beer, but actually you'll prefer to buy you beer than give you 1,000 bob. And those debts will last for 1,000 for years to come. And in fact, when you meet them, he's actually the person who will tell you, I have your loan. I have your loan. So we're looking at those kinds of people. We're trying to look at how we can look at your data and just know what kind of person you are. We were doing two things. We are doing it from a scientific view. No, they were both scientific, I think. One was mathematical, whereby you're doing this machine learning. And then the other one was basically based on pure psychology. There's this thing called psychometric tests, which we've been trying to wrap our heads around it. From a set of questions, being able, as much as getting your credit or risk profile, we're able to base it on your behavioral, your behavior pretty much influences how you borrow loans, or how you repay, or how you relate to other people. So for those who are maybe interested in what was this, I was told to give you an overview of what I'm doing. I believe I've done the best job, bearing in mind one sleeping, me being a very boring person at times. So I think I've done a good job. Yeah.
Yeah, so do you have any questions? The questions you had, this would be the time to ask them concerning technology aspect for loan. Do you have any questions? So just introduce yourself before you ask the question.
So my name is Timothy. So one of the questions I had is the features. So these are the features that you use for training your model.
Yeah, those are the
the names and the calls.
Yeah, those are a subset of the features. There's some which we dropped, things like location. We call the head no effect. So what we do is we have all the features, and then we try alternating, removing some features, adding more. So it's not actually everything. But we're also trying to extract more features for our data. But complete the question.
So then the output of your machine learning algorithm, is it a credit score or a 1 or 0 for probably if someone will default, if you're trying to predict that someone will default, they're going to default if a score of 1 is given, or if they're not going to default if a score of 0 is given, or is it a credit score maybe from a scale of 1 to 10, giving someone a score of maybe if it's a credit score of 9, then they are very good, they are credit worthy. Then if they get a very low score, they are not credit worthy. So what is the output of the algorithm that choice?
Yeah, so before I come to that, okay, let me tell you the idea we had. So our idea was basically to catch fraudsters. So we're actually determining the probability of default. So we give you whether, first of all, we have a volume, which is whether you're a defaulter or not. And then after that, we have the algorithms, accuracy. So you can be a defaulter, but the algorithm is 98% sure you're a defaulter. We run away from that. But we can give you not a defaulter, but with an accuracy of maybe 1%, we still run away from that. So it's like a balance. So it either tells us it's a defaulter or not, and then from then it gives us a percentage accuracy. Yeah. So machine learning is one of the things we use. So if at all it's unsure, like for things 98% or above 70%, we take it as true. But if it's lower than that, then we disregard it and we just proceed to use our own statistical models. Yeah. So it's like a balance. So machine learning is only because it only works best if the user has much data. Because even for new users, the accuracy is usually low. Like it's still more uncertain about the users, but I guess it will get better with training. So yeah. So
I have a comment. This one goes for you guys. Yeah. I'm thinking this privacy. It's so passionate to people, and you cannot technically solve it. My advice would be you need a more, you mentioned about psychological, you need to reassure the customer that the way he's thinking that data is important to him is the same way you look at that data. So if, for instance, if I go to the shopkeeper and tell him, nataka mandazi lakini sitakulipa, ama nitakulipa next week, atakupatia, sindio? Labda si mandazi. Lakini if 2 days later, you hear it from your neighbor, jamaa hata hizi mnao mandazi. When you go back to that shopkeeper, that's it. And then you're in business. So you need to psychologically address it while implementing technologically possible things that can actually reassure the customer that if you don't want, by the way, we believe you, everything is out. Just press this button. They will actually think twice. Next week they tell school fees. Sit at the button, Mr.
It's an interesting conversation that we like to have. So you can meet with our Twitter @Kiusnyongesa. So we can keep the conversation going because it's something that affects us, and we're happy to learn. If you're interested in data, if data fascinates you, you can talk to me. We are currently looking at people who can create more insights probably than what we know from our data. So yeah. So cheers. Thank you for being with us.
I think that's all we have for today for this particular edition of the Spotlight series featuring Loanbee. Feel free, after this, you can still network. You can still, we have some food at the back, so you can still eat while you're networking, and then you can give at your own leisure. Keep in touch through Meetup. We have our website, aikenya.io. We're on Facebook, AI Kenya. We're on Twitter, so you'll find us everywhere. We even have a Telegram group. So keep social, keep collaborating, keep discussing. I really liked the fact that we really had a good discussion today in terms of how does the technology that Loanbee is using, how does it affect your privacy, and you're raising the concerns. So that's very good. Yeah. Then I'd like to thank Microsoft for sponsoring this event, sponsoring the event coverage, so that the people who don't come to these events, they can still watch them. And you can still also watch this event after we are done. So a big thank you to Lawrence from Microsoft for supporting this event. Yeah, thank you. So you can network, you can have tea, and you can enjoy yourself. You can live at your own leisure. Thanks.